Hey, what's up?
Yo. So just
Not much. So this next section, it was the inequalities, or
I tried looking at it's a solving one variable.
hello?
Yo.
Hey, okay. Uh, okay. Let me. There's two geos. Does that matter?
I don't know. The one on the far left is letting me mute him. So I think it's because it threw me out and I rejoined maybe. I was trying to rejoin to the same.
Well, if we run into something, I'll try and switch it because I don't know which one
Okay.
is going right now. But so
So did you hear what I said? It's solving one variable inequalities.
okay. Are you have you shared anything yet or not
I
yet?
seen a quick video right now, but I just didn't because the guy kept so it was like 4x and then greater than like 2 or something, right? And then he did the same thing, which he got the x on its own.
Mm-hmm.
You know, he divided the 4.
There's so it's
It was a negative 4 or something.
yeah, it's there's like one thing that's it. It's the same exact steps for solving an equation,
Mhm.
except for there's one little thing that you have to pay attention to. So
He kept flipping that greater than.
yeah, and the reason you do that. Here, can I share something for like a
Yeah.
couple minutes
Okay.
and then we'll see. Share screen. Can you see?
Then he also like drew a number line. Yeah, I got it.
Okay. Okay. So some of the answers will be with the number line, I'm guessing. But um, so like, say we have this equation, like a regular equation, 3x plus 5 equals, let's say, negative 10. So the way we would solve this is you deal with the thing farthest away from the x, but on the same side of the equation. So you deal with this 5, and so you subtract 5. That cancels. 3x equals, and then negative 5, or sorry, negative 10 minus 5, that's negative 15. And then you would divide by 3, and that gets the x by itself. And that equals negative 15 divided by 3 is negative 5. So that would be the answer. Same exact steps if you have an inequality, let's say less than um, negative 10. I would do the exact same stuff, so I'm going to do it really quick. So that would be 3x less than negative 15 divided by 3 divided by 3. Nothing is different in this example. We'd have x equals, not equals, less than negative 5. That would be the answer here. So here, if you were to go back to the original equation and plug in negative 5, after evaluating, this side should end up being negative 10 because that's what it says it should be. So like if I were to plug this back in, this negative 5 into there, I would get 3.
Okay, you would get it.
Yeah, times negative 5 plus 5 equals negative 10. Let's see if this side comes out to be negative 10. So that's what we're doing. So negative 15, 3 times negative 5 is negative 15. Copy down the plus 5. And then negative 15 plus 5 is negative 10. So I get what I'm supposed to get. Here, in this scenario, this is saying I could plug in anything less than negative 5. So this is maybe why he drew a number line, because say I have like 1, 2, 0, negative 1, negative 2, negative 3, negative 4, negative 5. That's not good, actually. Let's say this is 0 over here, and so I'm counting down. So like 1 is over here, 2, and so forth that way. I'm just not going to draw that, just because I'm going to focus on that negative 5 part. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. If I plug in exactly negative 5 to this, I get a false statement. Like if I plugged in the negative 5 to this x, I would still get negative 10, just like I did here, right? Does that make sense to you?
Yeah.
However, this won't be an equal sign. It'll be a less than sign. So when I plug in this negative 5, I get negative 10 is less than negative 10, which is not true. Negative 10 is equal to negative 10. So that would be false. But I didn't plug in an answer properly because it doesn't say I'm allowed to plug in negative 5. It says I'm allowed to plug in anything less than negative 5. So if I plugged in negative 6, it's to the left side on the number line, which means it's less than. So if I plug in negative 6, then let's see what happens. So 3 times negative 6 plus 5 less than negative 10. So let's see what happens now and see if we get a true statement. So 3 times negative 6 is negative 18 plus 5 less than negative 10. Negative 18 plus 5 plus a positive 5 is negative 13. And that is less than negative 10 because on a number line, if you had, like, if you extended this, 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13 would be over here, like negative 13. That's on the left side of negative 10. So this is true. Does that make sense to you?
Yeah.
Okay.
The further down it goes, the less.
Yeah, the further left, that means less
on
than.
the negative.
So like -9 would be greater than -10, even though it's kind of like backwards because normally you think 10 is bigger than 9, but when they're negatives, it's the opposite. So everything's the same for inequalities, except for so like all the steps are the same actually. So we still did the -5 just like we did here, and we still divided by 3 just like we did here. So all that's the same. However, this is like the special rule. When you multiply or divide both sides by a negative number, you have to switch the inequality sign. Switch the inequality. So this is what I'm talking about. Like if this was a -3 right here, I would still do this step just like normal, and then it would be at this step. If this was a -3, then this would be a -3. That means I would have to divide by a -3, divide by a -3. If that were the case, I would have had to flip this inequality to be the other way.
Okay.
That's the only special rule. So like, if I have something like this, let's say 2 minus 4x is less than, let's say, -6. So on this one, I go about it the same way. I'm just pretending that's an equal sign, so I'm just doing all the same steps. Farthest away from x is what I deal with first, so I do -2, -2. That goes away. I have to carry down this -4x less than -8. And then now to get the x by itself, I divide by -4, and that goes away. -4. Doesn't matter whether this is negative or positive on the other side. Just the thing next to the x. That's what I'm dividing by. And this time, I'm dividing by a negative, because when you multiply or divide both sides by a negative, then you have to switch the inequality. So then we'll have x, and then I switch it to be greater than, and then -8 divided by -4 is +2. So that means, say like this is 0, 1, 2. I can't have something equaling 2. I could have something equaling 3. I could have something equaling 4, because it has to be greater than 2. So we'd do an open dot if we were to graph this on a number line. This is like another way that they'd be saying the answers. I think we looked at something similar to this before. But if I plug in 2, I'll get, if I plugged in 2, I would get -6 is less than -6, which is actually wrong. -6 is not less than -6. -6 is equal to -6. So really, I would have to plug in something greater than 2 to check my work. So I'm going to plug in just the next one. I'm going to plug in 3. So let's see what happens when I plug in 3. Times 3, regular 3, less than -6. So I'm plugging it in. This is just to check. So here I'm going to do this part first. -4 times 3. I mean, it's 2 minus 4 times 3, but since I'm doing the multiplication first, I'm going to consider this a negative. So -4 times 3 is -12. The 2 I copy down, less than -6. And then 2 minus 12 is -10, less than -6. Negative 10 is definitely less than negative 6, because like negative 6 would be here, negative 10 would be way down here. So this is a true statement that actually works, and it would work for 4, 5, 5.5, 6, anything that's bigger than 2. If we didn't switch the sign, we would have gotten something like this, and then we plug in stuff, and it wouldn't come out correctly.
Okay.
But this is the big idea. When you're solving, if you divide by a negative, you switch the sign. And I think we looked at how to graph the answers before, but we'll see when we get to another problem. I think that'll come back if you don't already remember that. All right.
See it?
Yeah.
All right.
Okay, I think on this one, you'd have to just solve it. Do you want me to walk you through it?
As is, yeah.
Yeah,
so
so
6x.
So 6x
greater than 3.
Yeah, and when it has the line underneath the little the arrow thing, that's the or equal to part. So this would be 6x greater than or equal to 3 plus 4 parentheses 2x minus 1. Do you have an?
So I do. We do the thing inside the parentheses, right? First.
Yeah, but so we're not plugging in anything. What do you mean?
So we gotta distribute the 4, right?
Perfect. And it's to the 2x, so 4 times 2x, and 4 times negative 1. And then just copy everything else down.
All right, so it'd be 6. So that'd be 8x.
8x.
And then negative 4.
Mm-hmm. So the whole thing, what would the whole thing be when you write down the rest of it?
6x greater than or equal to 3 plus 8x. Take away 4.
Yeah, minus 4.
So now I would do, so that's one of them right there, right? The second one.
6x greater than or equal to 3 plus, okay. So that's one of the answers. We're supposed to choose 3, okay. So now,
but if I wanted to keep solving this, right?
Yeah, because the rest of it will, like, you'll be able to see either more steps, like maybe A, that first one might be it, or something else. I mean, I think A is probably going to be there, and then one of those little arrow graphs is going to be it. But you have to keep going.
Is there any way I could add the 6 to the 8?
You could, but there's something that you can do first before that. You see the 3 and the minus 4?
Yeah.
Those, they don't have any variables on them, so they are like terms. So you can just combine those. So you just do 3 minus 4. Because you're leaving it on the same side.
You don't have to do it like the negative 4?
Yeah, you don't do the opposite. You do whatever's there, and it's a positive 3 and a minus 4. So you just combine them. 3 minus 4. You don't do the opposite because you're not moving it over to the other side of the equation or the inequality thing.
So then we do with a 6x, because that would be 1, right? 3 minus 4.
It'd be negative 1 because they're subtracting off
the
bigger. So it'd be negative 1. So you could write it down two ways. You could write 6x greater than or equal to negative 1 plus 8x.
Oh, okay.
Or you could write the negative 1 after the 8x, and it would just be 8x minus 1. Either of those is fine. Does that make sense?
What about where does the plus sign go?
The plus for the 8x.
Yeah.
Since it's positive, like you don't have to write it unless there's
Oh, okay.
something else in front of it. So like if you chose to write -1 plus 8x, you keep the plus because that means add. But if you write 8x minus 1, I mean you still could write plus 8x minus 1 because it's positive, but if you don't write it, it still means positive. That's just part of the notation. Like if you did like 3, I guess the 3 minus 4, that's the same thing as plus 3 minus 4. It's just we don't write the plus when it's positive unless we're adding something else to it in the front of it.
So then now I can combine the other two like terms?
Yeah, the x's, right?
Yeah.
Okay, so we have the -1 is on the right side of the inequality symbol. So we have to move the 8x to the left side. So you have to do the opposite. So it's a positive 8x. So you have to subtract 8x from both sides.
So I subtract 8x from 6x.
Yes. So you should get a negative number.
Right. -2.
So -2x greater than or equal to
-1.
-1. Now here's this is tricky. That is the same thing as that first. Actually, can I show you something real quick? You don't have to like pause it or anything. This will be quick, but can I share something?
Yeah, I'm going.
So you have -2x is greater than or equal to -1, right?
Yeah.
There's two things that we could do. Two different ways to do this. Like you could end up solving this, but the problem is it doesn't look exactly like part A or answer A. But here, if I wanted this to be positive, I could multiply by -1 because a negative times a negative is a positive. But if I did it on this side, I would also have to do it on this side.
Okay.
That's completely fine. I can do that for any inequality, any equation, as long as you do it to both sides. If I do it to one side, I have to do it to the other. But I'm multiplying by a negative number to both sides. And when you multiply or divide by both sides by a negative, you have to switch the inequality sign. So if I'm doing this, the only reason I'm doing this is to make it look like the answer for A. But -1 times -2x would be positive 2x. I have to flip this around. So this would be less than or equal to, and then positive 1. But then I would take this entire thing, because the signs are backward, or like everything's backwards. So like this, I could take this thing and maybe let's resize. I could, like, if we flipped it around, it would be 1. Well, that's not a good way. to actually show it. If I took this whole thing and flipped it around, this means the same thing as 1 greater than or equal to 2x. Do you see how that's the same thing?
Yeah.
So like you could read it 2x less than or equal to 1, or you could read it 1 greater than or equal to 2x, like if you read it backwards, because like Pac-Man eats the bigger number. So here, Pac-Man still is eating the bigger number. It just says 1 is a bigger number than 2x. So it's the same thing as that first, I guess, first answer. But, like, so the first answer, you can check that. But let's just finish up real quick, like the normal way, without doing all the fancy stuff to make it look the same. If you were just doing this, did all the steps correctly, you would then divide by -2. Because this is not actually solving it. We still have more to do. I was just making it look like that answer. So divide both sides by -2. We're dividing by a negative, so we have to switch this around. So x is less than or equal to -1 divided by -2 is positive 0.5, which means on the number line, if this was like 0, 0.5, I'd have a closed dot because it's the equal to part, and then less than smaller. So that's the third answer.
That's finally solved. Oh, okay.
And you would get the same thing if you took the first answer and divided both sides by 2. You would get 0.5 greater than or equal to x, which just means the exact same thing. If 0.5 is greater than x, then x is less than 0.5. It means the exact same thing. All right, let's see what's next.
It's the correct way, right?
Yep. Yeah, I think you have to solve.
So it'd be the same. Let's see.
So you'll have to distribute the 3 to the 8 and the -4x, or the -4x, and you'll have to distribute the 6 to the x and the -5. So you do 2 steps of distributing, and then variables to one side, numbers to the other. Do you want to try the whole thing and then I'll check you afterwards, or do you want me to walk you through? Okay.
We'll do it right now. Six times x would just be 6x, right? Or
yes. Yeah.
It's just. All right, so now I got 24. Subtract 12 or negative 12x.
Mm-hmm.
What is it? Less than 6x and negative 30.
Yep.
So now, can I do anything from here? I'd have to get the two the variables together.
The 2 variables together, and then you also, like the step after that would be get the 2 numbers together. It's just if you move the variables to one side, you have to move the regular numbers to the other side.
And I could just do that without doing anything, or do I have to like?
Well, let's say you're going to deal with the x's first. You could add 12x to both sides, or you could subtract 6x from both sides. Like one is moving the 12x over to the right, by adding it, and one is moving the 6x over to the left by subtracting it. So, like, pick which one you want to do.
So I did the add. Then I got the 2 on the left go away, and then I got 18x.
And then minus 30. Good. And then
and then minus 30, so 24 greater than.
Or less than, still.
Or less than, yeah. So now I deal with these guys, right? And I can do either one first?
Well, so now, since you move the 12x to the right side, you have to do the 30, or the minus 30, you have to move that over to the left side. So you have to add the 30.
Oh, okay.
You have to move it in the opposite direction.
The less than is right there. Okay. All right. So then add 30. $54 less than 18x.
Yep. And then one more step.
Yeah, I gotta get the x alone, right?
Mm-hmm.
So divide 18. X is alone. So I got 3 less than x.
Okay. So normally,
but since I divided, right, do I switch it?
No, because
that's only for the negative, right?
Yeah, if the 18 was a negative 18x and you divided by negative 18, then you would flip it. But you divided by regular 18 because it was a regular 18x, so you don't flip it. However, it might be easier to read. Whoops. Can you still hear me?
Yeah.
Okay, this session will end in like 10 minutes, but okay. I'll just restart it. I'll send you another link just because I'm using the free version. But so you could write. Well, actually, do you know which graph, which number line goes with the answer that you have?
So it's 3 less than x. So I would assume it'd be the second one.
3 is less than. Yep. And the way that I make sure, like, you can just test it if you have the graph here. Like, you can test it out a little bit. Like, if you plug in the 4, is 3 less than x? Well, if you plug in 4, is 3 less than 4? Yes, it is. If you plug in 5, is 3 less than 5? Yes, it is. The other way is if you were to flip everything around and write the x first, but make it so that, like, Pac-Man still eats the bigger thing. So, like, it's 3 less than x. Pac-Man's eating the x. So if you write the x first, Pac-Man would still have to be eating the x. So it would be x greater than 3.
Greater than.
And now the greater than, as long as the x comes first, the greater than sign, or the inequality sign, should point the same direction as the arrow points, like the blue arrow. But that's only if you write the x first. So you solve it however, but then you can flip it around, or you can just, like, think about it and know which one to write. So this one, what value of x is in the solution set of this? Okay.
Just have to plug.
You could plug it in, yeah. And just make sure that whatever you get for the left side has to be greater than or equal to whatever you get on the right side. Does that make sense?
Could I plug it in, or could I just solve it without?
You could solve it. And, like, if you want to practice solving it, then yeah, I think you should solve it and then see which one fits afterwards. Like, it'll be easier to tell if you just solve it first, and then you'll be able to just, like, look at it and see which one.
All right, so I got 6x negative 2 for that when I distributed the 2, right?
Yep.
So then it's the greater sign, 4x negative 6. So again, I'll deal with the x's first.
Sure.
And either one works, right? So
Yeah.
I'll divide 6. X.
Well, you're not dividing 6x, right?
Oh, I thought I was because I'm just adding, right?
Well, it's a positive 6x. You want to move the 6x over to the right side? Is that what you're trying to do?
So subtract?
Yeah, subtract 6x
because it's
from both sides. Yeah, it's a positive
okay,
6x.
Okay.
So you subtract the 6x over.
So I get negative 2x. So now I got the negative 2 greater than or equal to negative 2x, negative 6. So now I'll add the 2.
You can't. So you already.
Or I'll get the 6. The 6.
Yeah. You already went from the left side to the right side, so now you gotta
so now
deal with that negative
side
6.
So that'd be 4.
Yeah.
4 is greater than negative 2x. Now I have to get the x alone, right? Add 2.
So you don't add 2.
Oh,
so
this one is going to be divide, right?
Yeah, because it's negative 2 times x. So it's just like when you had the equations. If it's right next to the x, the opposite would be dividing, because when it's right next to the x, it means multiplying. So negative 2 times x, you have to do the opposite to get the x by itself. So you divide by negative 2. But here's the special thing. You're dividing by a negative, so you have to switch the sign around, the inequality sign.
Even before I divide?
Well, you can do it just when you write down your next.
Yeah,
when you write down your next thing, don't forget.
Okay. So then it's 2 is greater or equal than to x.
But you did 4, and it should be divided by negative 2, right?
Yeah, and I got negative 2.
Okay, so negative 2, and then you got to flip around the inequality.
Oh, that's what you do too. So 2 is less or greater than x?
It's negative 2. So you switch the inequality symbol, not the sign of the
plus,
number.
Yeah, not the sign. Yeah.
So it's negative 2 still, but then instead of a greater than or equal to, it's now a less than or equal to x.
So once it's there, how the hell do I keep going?
No.
I can divide by. Can I do the? I can't even divide.
Well, x is by itself. So now you just have to figure out, if you plug in a negative 10 now, is negative 10 the bigger one when you compare it with negative 2?
No, it's smaller than 2.
It's smaller. It's more negative, so it's smaller. So what about with the negative 5? Is negative 5 bigger than negative 2?
Nope. So it'd be negative 1.
It'd be negative 1. Does that make sense?
Yeah. I was just confused because we flipped it to it's a regular 2 plus it's a 2 now, right?
No, it's still a negative 2.
Well, it's a negative 2, but then we flipped the inequality sign.
Yeah, negative 2 less than or equal to x. The only one, negative 1 is the only thing that's bigger than negative 2 out of those answers, because it's less negative. It's more to the right on the number line. So like -2 is smaller than -1 because -2 is more to the left on the number line. All right, I'm going to end this and then send you another link real quick.
Okay.
Hello?
Yeah, but
Okay.
so this would be the same. I just had to solve. Huh?
Yeah. Hello?
I don't know why it keeps doing this.
Oh, now I can hear you. Just the image is still frozen.
Well, now can you see it?
I could see the problem. It's just it's not the time remaining is not going.
It's still frozen on there?
Yeah, maybe it'll. Have you tried stop sharing and then? Oh, 3 participants.
Yeah.
Maybe I have to.
That's why it kicked me out again with that stupid thing. And then I tried sharing.
Okay, wait. Say something.
You hear me?
Okay, yeah. I'm going to remove. Hello.
Yeah.
Okay, now try sharing. There we go.
Oh, right. What was it doing? Okay. All right. So I'm gonna do the same. I got negative 4x, negative 12,
Mm-hmm.
less than or greater than negative 2 and negative 2x.
Mm-hmm.
So I'm gonna do the 2. Well, I mean, the 4. I'll just add 4x.
Okay.
Cross that out. And then I get 2x,
Mm-hmm.
12, negative 12. Less than or greater than. So now I gotta add the, this time I'll divide the negative 2, right? Oh, no. I can add the 2, right?
Add the
To
2
the
to
12?
both sides to the negative 12. Yeah.
This negative 10 is greater than or less than or
Yeah. Less
equal to
than or equal
2x.
to.
Now I'm gonna divide the 2x for the 2.
Divide by the 2. Yep.
So it should be negative 5, I think. Right?
Yeah.
Negative 5 less than or greater or equal to. So it'd be the second one.
No, because it's that.
Oh, no, it's negative. It's
Yeah, the
negative.
dot should be on the negative 5. So it's either the
Yeah,
first
so
one or the last one.
it's less than. So it would be the first one.
Mm-hmm. The way I do it is like I read it with the x first. So the x, if I'm reading it like with the x first,
Always.
x is the bigger one out of the negative 5. So on the numbered line, you should be shading above the negative 5 because x is the bigger one.
Okay. So the arrow should go that way.
Uh, the arrow should go to the right because x is the bigger number. Like the Pac-Man is eating the x, so x is bigger than the negative 5. So you should shade on the bigger side of negative 5.
Okay.
You should just solve it all the way and figure out which of the last two, and maybe you'll figure out one of the other ones as well, just like we did on the other one. Do you have anything yet?
Yeah, I got negative 6x, negative 15, less than, or I mean greater than 10, negative x.
So first, It should be, so you did the negative 3 times the 2x, and that's how you got the negative 6x. Yeah?
5x it should be, right?
And then
Yeah.
negative 3 times the negative 5 should be positive 15.
Okay, so that goes away.
Well, you said negative 6x and negative 15. It should be negative 6x and positive 15.
Yeah, I see. But that little the sign next to the 5 doesn't stay there. It just I know it turns positive, right? That's just there.
Yeah,
that's what always confuses me. So it's gone.
Yeah. Well, I think here. Let me solve this because this is a good thing to talk about, but I don't want to like waste time on it. So select the third answer, and then let's do.
This one should be one of them.
Is it x squared?
This is the second step I got to.
Yeah, that third answer is right. Let me just. Yeah, those are the two. Okay, save it, and then I want to show you something. So it was, it was, I think, negative, oops.
It was negative 3. 2x.
2x minus 5.
5.
And then it was, I think it was 5.
Yeah, it was 5, yeah. There you go.
Okay. So here's the thing. This part, the way you read it is 2x minus 5. This negative is also a minus sign because there's another number over here. So like this, you would say 2x minus 5. But this minus is also a negative for the 5. Here, this is just a negative 3. The reason you don't say minus 3 is because there's nothing out in front here. It's not like 1 minus 3 or 10x minus 3. It's just negative 3 because there's nothing in front of it. When you distribute, though, that's the thing that's confusing because right now, the way that you can read it is negative 3, because there's nothing in front of it, times the quantity, so like the parentheses, 2x minus 5. So that's the way you read it. But when you distribute, you can think of it as this as one piece and this as one piece. So when you read it all together, you would say 2x minus 5. But when you're distributing, you think of a 2x and a negative 5, and they're separate. So when you do the distributing, when you multiply, you're doing negative 3. This is like on the side. You're doing negative 3 times 2x. That gives you negative 6x because you just do the negative 3 times the positive 2. And then you do the negative 3 times the negative 5, and that gives you positive 15. Actually, so we could just write regular 15. But since there's a number in front of it already, we'd have to include the positive. And then now it becomes negative 6x plus 15. This negative was a minus sign and a negative sign at the same time. So when you say like, so that negative goes away, yes, because we multiplied this negative number and that changes it to a positive 15. So this is a positive 15 and a plus 15 at the same time. It's negative 6x plus 15. But if you were just to think about this part, then you could say, yeah, it's a positive 15. Does that make sense?
Yeah.
And then here, the way you would read it is you'd say 2 minus x. But when you distribute, you do this 2 and this negative x those are two separate things, and you can think of this as a negative 1 in front. When there is no number, it's always a 1. So then 5 times 2 is 10. Or you could write plus 10, but there's no number in front of it like immediately, so it doesn't make sense to say like a plus 10. We already know saying 10 means it's a plus 10 or a positive 10. So you just write 10, and then regular 5 times a negative 1 would be a negative 5, and then you tack on the x. However, this is both a minus 5x, like 10 minus 5x, but if you think of it individually, you can think of it as a negative 5x. So it's both of them at the same time, which that's like the confusing thing, but it's both of them at the same time. This one and this combine to make this plus 15, and then this one and this combine to make a negative 6x, because a negative times a positive is a negative. You reuse this negative. It doesn't go away. It's not like, maybe that's confusing too. It's not like you do negative 3 times 2x and this negative now is used up. That's not true. It's still a negative 3 when you multiply it to this one as well.
Okay.
And then from here, like the steps were to, I think you probably would have added 6x to both sides, because this is the way you had been doing it. So then 15 less than 10, and then now we're considering it separate pieces again. So now it's like not really a minus 5x as much as it's a negative 5x, because we're just dealing with this piece. So negative 5x, and you can think of it as a plus 6x or a positive 6x. You're combining them the same way. It's weird how the notation means it's like both simultaneously, and you can switch back and forth. But here we're thinking of negative 5x plus 6x, and that gives you a positive x, or 1x. And since we have something in front, we put a plus. And then subtract 10 from both sides, and you get 5. So x is bigger than 5, and that's what it was like, something like this. That way. Greater than, so it's an open circle. I feel like it's like pretty confusing with the way that you can read it both ways.
How you wrote out the the 6x plus 15 helped out, because I thought the negative was going to stay there.
Okay.
But it turns into, I know negative and negative turns into a positive.
Yeah. All right.
Which sometimes, I guess it's confusing.
So yeah, when you're adding and subtracting, like two negatives don't make a positive; they make another negative. But like, maybe the best way to do it, if you like get confused with those, is just to keep doing it with the calculator. But
okay. So it's only more.
When you multiply, a negative and a negative make a positive. If you're adding or subtracting, a negative and a negative, they just make another negative.
Very negative. Okay.
And the weird thing is, like, you could do negative 3 minus 2. You can say those are both negatives because it's minus 2 and negative 2 at the same time. So it's confusing, I feel like, but we'll see what we can do for the rest of this. Okay, on this, I would say change the negative 1/2. Change it to a decimal.
0.5.
Yeah, to negative 0.5. And then, what do you think you do?
I would add the 0.5, right, to the 4, to itself, and then the 4, right?
Well, it's right next to the x, right? So negative 0.5.
Oh, division. Yeah, you would
Yeah,
divide.
so
Yeah,
you
that was
divide.
do that.
And it's a negative 0.5 that's right next to the x. So we're dividing by a negative. What does that mean you have to do?
Okay. You gotta flip the negative to a positive.
Not the negative to the positive. You flip the greater than or equal to a less than or equal to.
Oh, okay. Okay, see, that's confusing now too. Okay, so it's still before to the negative, right?
Yeah, 4 divided by negative 0.5, and so you get, I think, like negative 8.
Negative 8, yeah.
Okay, so that stays
So
negative
now we
8.
flip. So now it's x. It's less or greater or equal to negative 8.
There you go. So which line corresponds to that?
So the Pac-Man's eating the 8. So would it be the first one, huh?
No.
Well, no, because what's the last one then?
The Pac-Man's
it's
eating
negative
the
8.
8.
It's negative 8. Yeah, it's negative 8. I'm over here.
Yeah, so if the Pac-Man's eating the negative 8, that means negative 8 is bigger than all the x values, right?
Yeah.
So the x values, if you read it just from the x point of view, just read x is less than or equal to negative 8. Less than, yeah, would be to the left side, smaller, more negative. So it's that second answer.
Yeah, I don't know why I went off this one. It's not even right.
I tend to try and read it from the x first. Like I start with the x. And so like x, well, the Pac-Man's not eating the x, so that means x is less than the 2. If the Pac-Man was eating the x, then it would be pointing the other way.
Right. Good way to look at it.
All right, you don't have to distribute, but it's still the same idea.
So it's already written out, right? So I would have to do, okay. So I could do the 4x added to the 8. Oh, no, divide because.
So when you're getting the variables to one side, if you're moving them from one side to the other,
yeah,
you do the opposite, and it's a positive 4x. So you'd subtract 4x to both sides. Because you're not, like, getting the x by itself right now. You're moving the x's to the same side. When you're getting the x's by itself, or when you get the x by itself, that's when you divide.
So when you're combining them.
When you're moving them to like one side or the other, you don't divide. You add or subtract.
Okay. So we're subtracting 4x.
Subtracting 4x, yeah.
Which will leave 4x.
Mm-hmm.
So now I got 12, 16.
It should be negative 12.
Plus 8. Yeah, negative 12.
Okay.
Less than or equal to 16. Plus plus x4. Or 4x.
Yeah, plus 4x.
So now I'll subtract the 16, right?
Yep.
And does that become a negative because I'm subtracting, or is it still just negative 12?
So you can
minus
you
16.
can think of it as negative 12 minus 16. That'll give you a negative. You can think of it as negative 12 plus negative 16. That'll still give you a negative. We're not multiplying. The only way it would
Yeah,
change
you're
to a
right.
positive is if we were multiplying negative 12 times the negative 16. So it
All
should,
right, so I got negative 28
yes.
less than or greater than 4, so I'm going to divide it by the 4.
There we go.
Negative 7.
Mm-hmm.
Since we did that, do we flip the, since we divided?
So the number that we were using for the division was the 4, and the 4 is positive, so we leave the
Where it's
inequality
negative.
the way
Oh,
it
okay.
was.
Okay. So it'd be the negative 7.
So negative 7 less than or equal to x.
Yeah.
If you put in the negative 10, yeah, yep. Because the equal to part, the line on the bottom makes it so that you can
Yeah, you're right.
have them both the same on the both sides of the inequality. Yep. Same idea.
We're going to add the 20 and the 5.
Mm-hmm.
Now again, negative 15
Mm-hmm.
greater than 10 plus 40 plus 15 x.
It should be plus 25x because you had to add the 5x over.
Oh, okay, and that takes away the positive. The negative, I mean.
Yeah.
Let's see this right. Okay, now I'm going to do the subtract the 10.
Okay. Because it's a positive 10, so you do the opposite. So minus 10, good. And then minus 10.
I got negative 25.
Yep. So read it all out.
Negative 25 is greater than positive 25x.
Mm-hmm.
Divide the 25.
Uh-huh.
Negative 1.
Mm-hmm.
Greater than x.
Yep. So now if you plug in those x values
To the,
for the x.
oh yeah, negative 1 is greater than, so it'd be negative 2, right?
Yep. Cool.
These ones you gotta solve every one.
Yeah. Oh, well, maybe this one, it's just asking for the first step, so.
Oh, okay. Yeah, you would distribute the 4.
Mm-hmm.
what would you be?
When you distribute, you're multiplying. So, like, what do you think? You can do the -4 times the 2x. Then you write
So
that down.
and we got, so it's a, or no, it's
And then
it should be a, right? Because you do get the -8, and then the 4 becomes a positive.
Because -4 times -1 is +4. So you write -8x plus 4. Yep. Again, you're gonna solve.
Figure it out. Okay. 9 times 2 would be 18. I got 18x plus 9 less than 9x -18.
Mm-hmm.
Okay. So since they're positive, we're going to subtract the 18 from the 9? No, right? We're just adding?
So
Where's my text?
the 18x that's on the left side, it is positive
Yep.
right now. So you subtract it, minus 18x.
Okay.
And you're doing it from the left side, so they cancel, and then minus 18x underneath the 9x.
So now I got 9 less than 9x -18.
It should be negative 9x.
Okay.
So if you do 9 minus 18, then it is negative 9. And then, so negative 9x minus 18.
Negative 9x. Okay. So now I'm going to add the 18.
Mm-hmm.
Negative 9. No, to the freaking regular 9.
Mm-hmm.
So 27 less than negative 9x.
Mm-hmm.
Now we're going to divide.
And what are you using to divide?
The negative 9.
Negative 9.
That -3
Mm-hmm.
is less than x.
Except for when you're dividing using
So
when that bottom number is negative, then that's when you change the inequality symbol.
that's the greater, and so it'd be -3 is greater than x.
Yes.
So it'd be -4 then.
Yep.
That part will always get me, I think.
Yeah, that was a pretty heavy one, I feel like.
Yeah, I got to figure it all out. I usually have a couple simple ones.
Yeah. All right, let's see what the next section is. I don't think I'll be able to do the next one, but I do want to see what it is.
Oh, it's going to be doing the unit test before, so this is the unit test.
Oh, right.
The actual test.
Okay, well, I should be available tomorrow if you can.
All right. Yeah, for sure.
All right, I'll talk to you later.
Is this one? This is just a simple one, right? What we're doing right now, right?
Well, This was
Oh,
the
this is the one we
absolute
did
value. This
yesterday.
was from
Yeah, all right.
yesterday.
Okay, I'll look it through. Don't worry.
Okay.
I should figure it out. Cool. Thanks, man.
Yep. I'll talk to you tomorrow.
All right.
Bye.